Welcome dear students, we are on the CEC Gurukul lectures. We are in the series of electronic physics and today's lecture is diode. Means we are discussing the electronic instruments which are used in the electronic circuit. So today we discuss about the diode. What is the diode and what type of diodes and how we can use in the electronic circuits. So we start, what is a diode? Then diode is made of the two words. First is di, that means two, and ode means electrodes. What electrodes? Electrodes means we are having the two electrodes, two components of the device. One is a cathode and second is the anode. So diode made up of the cathode and anode terminals. So diode means di plus ode is the diode. A diode is an electronic device having the two terminal unidirectional power supply. It means when we apply the power, it is a unidirectional power supply we use in the diode. The semiconductor diode is the first diode that forms in the semiconductor electronic devices. After that, there are lots of new inventions takes place, but the most common diode use is a semiconductor diode. So why it is a semiconductor diode? Because we use the semiconductor material to prepare the diode. So by using the semiconductor material, we prepare the diode. So most commonly used diodes are the semiconductor diodes in the circuit. A diode has a two terminal that have a low resistance to the flow of the current in the one direction. There is a low resistance on the one side and high resistance on the other side, restricting the flow of the current in one direction and the flow of current in the other direction. So semiconductor diodes are having the two terminal that consist of P N junction. You all know about the P and N, and we will discuss further also what is P, what is N. P for the P N junction, positive and negative terminal of the junction, and the metallic contacts at their ends. As you can see in the diagram also, that the diode is made up of the P N junction and the metallic contacts are attached both of the ends of it. Materials which are used to make the diode, we are talking about that it is a semiconductor, so we use these semiconductor materials to prepare the diode. First is a germanium, silicon and gallium arsenide and so on. The many semiconductors can be used to prepare the diodes. Then in general, all the electronic devices need the DC power supply. Then what is the function of this diode? It converts AC power to the DC power, because most of the devices need DC power supply, but it is impossible to generate the DC power. So we need to convert the DC to AC, from AC to DC power. So we need an alternate to get some DC power. Thus the uses of diodes, we can convert the AC power into the DC power. A diode basically is a tiny component in the electronic devices and is unable to flow of the current in only one direction. That's why it is called the unidirectional devices. Or now we can say that the uses of the semiconductor material to build the electronic components was started with the diodes. So before the invention of the diodes, the electronic circuit, we use the vacuum tubes, which where the application of both these devices are similar, but the size occupied by the vacuum tubes were much greater than that of the diode. So vacuum tubes replaced with the diodes, and the working is same. The construction of the vacuum tube is a bit complex and they are difficult to maintain when compared with the semiconductor diodes. So after the invention of the semiconductor diodes, we can have the many application of this diode. The diode can be used in the rectification, diode can be used in the amplification, electronic switches, conversion of electrical energy into the light energy and light energy into the electrical energy. If you say without diodes, electronic circuit is nothing. Means there are lots of application of the diode where we can use it: rectification, amplification, electronic switches, conversion of the electrical energy into the light energy into the electrical energy. So what is the history behind the diode? In 1940 in the Bell's lab it was discovered by the Russell Ohl, and who was just using the silicon crystal to find out its properties. Accidentally, when the silicon crystal which was a crack in it was exposed to the sunlight, and he found the flow of current through the crystal, and that was later called the diode, which was the beginning of the era of the semiconductor. So how we construct the diode? What is the construction of the diode? Basically, we use the solid material, that is the semiconductor material. The solid material are generally classified into three types. The solid material classified into the three types. First is conductor, second is insulator, and third is the semiconductor. What is the conductor? Which is having the maximum number of the free electrons. What is the insulator? Which is having the minimum number of the free electron. Negligible, such that the flow of current is not possible in the insulator. Whereas the semiconductors are in between that, which can be either conductors or insulators. Depends upon the potential applied to it. It means semiconductor is in between the conductor and insulator. It can work as a insulator as well as a conductor when the potential applied on it. So these semiconductors are used to prepare the diode. Semiconductors which are in general uses are the silicon and germanium. Silicon is preferred because it is abundantly available on the earth and gives a better thermal range, and it is cheap. So mostly silicon is used to prepare the diode. Now semiconductors are classified into two forms. Number one is intrinsic semiconductor, second is extrinsic semiconductor. What is the intrinsic semiconductor? These are also called the pure semiconductors, where we are not adding any impurity on it, where the charge carriers, electrons and holes are in the equal quantity at the room temperature. So current conduction takes place by both holes and electrons equally, and they are the pure semiconductors. Apart from this, we are having the another type of semiconductor, that is the extrinsic semiconductors. In order to increase the number of holes or electrons in the material, we go for the extrinsic semiconductor, where we use the impurity in the where impurities, then silicon and germanium are the simply trivalent or pentavalent materials are added to the silicon, so that the number of charge carriers can increase in it. These impurities are added into the semiconductor on the silicon as we are taking. This process of adding the impurity to the pure semiconductor is called the doping. Then that type of the doped semiconductors are also called the extrinsic semiconductor. Intrinsic means pure semiconductor, and extrinsic means where we add the impurity in it. Why we add the impurity? Just to increase the number of holes and electrons in the material. So what type of impurity we can add it? We add the trivalent or pentavalent materials into the pure semiconductor. And that process is called the doping, when we add the impurities in the semiconductor, in the material. Now formation of P and N type semiconductor. As we discussed that the diode made of the P and N junction. So how P and N junction formed? So we discuss here. Now N type semiconductor, how we get? If pentavalent elements, number of the valence electrons are 5, are added to the silicon or germanium, then there are the free electrons are available. As the electron negatively charged carriers are more in number, these are called the N type semiconductor. when we increase the n type of negative charge carriers in the semiconductor, then by adding the pentavalent element, then it is a n type semiconductor. In the n type semiconductor, electrons are majority charge carriers and holes are minority charge carriers. In the n type semiconductor, charge carriers, negative charge carriers means electrons are majority charge carriers and holes are minority charge carriers. And few pentavalent, now you can see in a diagram that here this is the structure where we has the pentavalent impurities in it. Now you see few pentavalent elements are phosphorus, arsenic, antimony and bismuth. Since these have the excess value electrons and are ready to pair with the external positively charged particles, these elements are called the donors. Now p-type semiconductor, here we see in the diagram that phosphorus, arsenic, antimony and bismuth are added, and these are called the, when these have the excess valence electrons and they are ready to pair with the external positively charged particles, these elements are called the donors. Now in the p-type semiconductor, here similarly as there we had the pentavalent, here we had the trivalent elements like boron, aluminum, indium and gallium are added to the silicon or germanium. A hole is created because of the number of the valence electrons in it are 3. So number of holes will increase. Now since a hole is ready to accept an electron and get paired, it is called the acceptors. So n-type is the donor and p-type is the acceptor. As the number of holes are excess in newly formed material, these are called the p-type semiconductors. So in the p-type semiconductors, holes are majority charge carriers and the electrons are minority charge carrier. Again, n is the donor and there n-type, in the n-type semiconductor we are having the electrons are majority charge carriers and holes are minority charge carriers. In this p-type it is acceptors type, and here the holes are majority charge carriers and the electrons are minority charge carriers. So now you see formation of the p-type semiconductor. Now you see the excess holes are there, in there the electrons are there. Now here we are having the excess of holes are there and it works as a acceptor. Now p-n junction diode. Now if we join these two type of semiconductor like p and n type together, then a new device is formed that is called the p-n junction diode. Since a junction forms between a p-type and type material, it is called a p-n junction. So that's why it is called a p-n junction, because we attach p and n type semiconductor together. Now the diode can be, as we know, now we get here it is very clear that diode means di, do, two, and odd means electrodes. P and n type electrodes are attached here, so it is called a p-n junction diode or semiconductor diode. Diode, p-n junction diode or semiconductor diode. This is the diagram. Here you see on the left hand side p and n are attached and two terminals are there, anode and cathode, and this is the original form of the diode. The terminals connected to the p material is called the anode, and the terminal connected to the n type material is called the cathode. Now see the symbol of the diode is, you see on the lower diagram, that this is anode, cathode, and this is the symbol to represent the diode in an electronic circuit. Now the arrow indicates that the flow of current through it when the diode is in the forward biased mode. The arrow indicates the flow of current through it when the diode is in the forward biased mode, and the dash or the block at the tip of the arrow indicates the blockage of the current from the opposite direction. There is a blockage of the current in the next direction, one where flow and there is stop of the current. Theory of the p-n junction diode. We have seen how a diode is made with the p-n semiconductor, but we need to happen what happen inside it and what are the unique properties which allowing it to flow of the current in the one direction. What happened? Exactly the point of contact initially at its junctions. So how it works? First we discuss about the junction function. So initially when both the terminals are joined together without any external voltage applied, the excess electrons in the N type and the excess holes in the P type will get attracted to each other and gets recombined, where the formation of immobile ions like donor ions and the acceptor ion takes place, as we have in the figure. These immobile ions resist the flow of electrons or holes through it, which now acts as a barrier in between the two materials. Now formation of barrier means the immobile ions diffuses into P and in region. So barrier which is now formed is called the depletion layer. You see here in between these two P and N type there is a depletion region, that is a depletion layer where the hole and electrons can be combined. There is a barrier where immobilized ions restrict the flow of electrons or holes through it, which now acts as a barrier in between the two materials. So this is the depletion region. The width of depletion region in this case depends upon the doping concentration in the material, means which type of biasing we are having, forward or reverse biasing, where the electrons are more or the holes are more. On the basis of that we can define the width of the depletion layer. Now you see in the diagram that this is the P type and right hand side N type, and cathode terminal is attached, the anode terminal is attached, and in between that there is a depletion layer. So plus sign for the positive holes and negative sign for the electrons, and PN junction diode when unbiased, when the no potential is applied. If the doping concentration is equal in both the materials, then the immobilized ion diffuses into both the P and N material equally. Now what if the doping concentration differ with each other? Holes is more as compared to the electrons, or electrons more as compared to the holes, then what will happen when the doping concentration differ from each other, when the P and N type concentration are different? Well, if the doping differs, the width of the depletion region also differs. It diffuses is more into the lightly doped region and less into the heavily doped region, where it is that we will define that the doping differs the width of the depletion region as it diffuses more in the lightly doped and less when the heavily doped. So on the behavior of the diode depends upon the voltage applied. So that we will define by the two method, diode in the forward bias and diode in the reverse bias. We can biasing the diode by for forward biasing or by the reverse biasing. Then what is the forward biasing? To make the forward bias, first we need to break the barrier formed in the path. The break of the barrier within a normal diode is minimum of the plus 0.7 volts for silicon and 0.3 for the germanium. External voltage should be applied to the terminal. Now this much external voltage applied to the silicon or germanium respectively, these voltages are called the cut-in voltage, offset voltage, breakpoint voltage, or firing voltage, or threshold voltage. Generally we use the threshold voltage. Until these voltages are very less, current flows through the diode ideally zero. It means very less current will flow inside the diode because of this low voltage applied. Now you see here in the diagram that if a positive terminal of the battery or the voltage source is applied to the anode or the P region of the diode, the negative terminal to the cathode to the N region of the diode, then it is called the forward biasing. Here you see on the screen, you see that here in between the charge carriers are there, P type and N type, and in between that there is a there is a depletion layer. If the positive terminal of the battery or the voltage source apply to the anode or the P region, if the positive terminal attached to the P type, negative terminal attached to the N type region, then it is called the forward biasing. As you see in the diagram, the negative attached to the negative and positive attached to the positive. You see. Next, due to the forward biasing, majority charge carriers in both the region get repelled because positive charge is applied to the P region and negative charge applied to the N region and enter into the depletion region. Hence, immobile ions get back lost carriers because neutral and move to the undepleted region. Hence, width of the barrier decreases gradually. In the forward bias, the width of the depletion layer decreases gradually because of the neutral and move to the undepleted region. So, the width of the barrier gradually decreases. When applied voltage is greater than that of cut-in voltage, entire barrier is destructed and the electrons and holes are now free to cross the junction, which then forms a closed circuit and enable the flow of current. As soon as the voltage applies an increase, then holes and electrons are free to move, free to cross junction, which then forms a closed circuit and enables the flow of the current. Diode is a forward bias, acts as a closed switch and has a forward resistance of the few ohms. In the next, the reverse, now the opposite terminals are attached, means positive attached with the negative and negative attached with the positive. If the negative terminal of the voltage source is applied to the anode or the P region of the diode, the positive terminal to the cathode or the N region of the diode, then it is set to the reverse biasing. When such voltage is applied, the majority charge carriers in both the region get attracted towards the source, such that a large number of the immobile ions are created and enter into the P and N region. Therefore, the width of the depletion layer increases gradually. In the forward biasing, the width of the depletion region are decreased, and in the reverse biasing, the width of the depletion layer increases, which is now difficult for the electrons and holes to cross the junction. So, open circuit forms and the current flows. In the forward bias, we are having the closed circuit. Now, here we are having the open circuit as the depletion layer width increases. So, but if you go for increase the voltage at the point of barrier, depletion region cannot withhold the external force and the junction breaks down, which may sometimes cause a normal diode damage permanently. To overcome this, we heavily doped N region and put the diode safe. This application can be used in the Zener diode that we will discuss later. So, the reverse voltage at which the diode conducts is called the breakdown voltage, and Zener diode work on the breakdown voltage. As a diode in the reverse bias acts as an open switch, its resistance is in the order of the mega ohms. So, when the reverse voltage is applied to the diode, small amount of current flow in the circuit due to the minority charge carriers, which is generally called the reverse saturation current. When the reverse voltage is applied to the diode, small amount of the current flows in the circuit due to the minority charge carriers, that is called the reverse saturation current. So, you can see here these currents are also called as the leakage current, because even when the diode is open circuited, current exists in the circuit, so it is termed as a leakage. Now, this is a characteristic that we also discuss in the what are the applications of PN junction? PN junction diode is a two-terminal polarity sensitive devices. The diode conducts when it is forwarding biases, diode not conducts when reverse bias due to its characteristics. PN junctions have many applications in the rectifiers in the DC, demodulation circuit, clipping and clamping network. Different types of diodes are there. So, these are the application of the PN junction diode. Thank you very much.